Hello lovely people, what is up? Today we are solving Leetcode problem number 122, sum of root or leaf binary numbers. So we are given the root of a binary tree and each node contains either 0 or 1, and every root to leaf path forms a binary number. So our task is to convert each binary number into decimal and return the sum of all of them. So for example, if the path is 1 0 1, that forms binary number 101, which is equal to 5 in decimal. And we repeat this for every root to leaf path and add them all. So since we must explore every path from root to leaf, this is a perfect case for depth first search, because depth first search goes branch by branch, which matches our need to build a number along a single path. So the core idea here is to start with a number 0 and at each node shift number left by 1 and multiply by 2 and add node value 1 or 0. So if we are looking at it step by step, we start DFS from root with value 0, and at each node we shift the current number left and add the node value. If we reach a leaf node, we add this number to the result. Otherwise, we continue DFS to the left and right child accordingly. We repeat this process until all paths are explored. So for example, in the given example 1, if we take the root node and move left and left, which is 1 0 0, the final 0 being the leaf node, we can add it to the result. That is, result will be initialized to 0 at first. So 0 plus 1 0 0. 1 0 0 decimal conversion is 4. So 4 plus. Then we move to the next node, which is 1 0 1. Since we had previously visited the left node, now we are visiting the right node. So it becomes 1 0 0 plus 1 0 1, which is 4 plus 5. And then again we go from the left node to right node because all the paths on the left parent node are explored. Now it becomes 1 1 0. First we visit the left node, so 1 1 0, which when converted to decimal becomes 6. So now it is 4 plus 5 plus 6, and then finally it is 1 1 1, which is 7. So the total value is 4 plus 5 plus 6 plus 7, which is 22. So now if we take a look at the time complexity for this particular algorithm, it will be O of n, because at each node we only do one shift and one OR operation, and it is constant time checks. So when we say O of n time complexity, it means runtime grows linearly with the number of nodes. The space complexity is constant space O of n. So now let's take a look at the code. So first we create a variable result to store the sum of all root to leaf binary numbers. Why are we doing global, that is self.result? Because we want to update this value from inside the recursive DFS function. Yes, we are going to code a recursive DFS function that we can call in the code. Now we define the recursive DFS function, which is define DFS, and the parameters are node and current. So we use this function to explore the tree. Node stores the current tree node and current stores the number found so far from the root to the present node. And then we initialize an if statement to specify if the node is none, that is there is nothing to process. If not node, we stop recursion and we just return. This avoids errors. And then we define the core logic. So we update the current. Current is equal to current is shifted to the left and it is the same as multiplying by 2, and it makes space for next binary digit. So we do in parentheses current is 2 smaller than symbols and 1. So it means we are moving it to left by 1. And then to add the current node's value, that is 0 or 1, we do OR of node dot val. Then to check if the current node is a leaf, we are using an if statement. If not, node dot left and node dot right. This means no left child or no right child. So the path is finished. So when we have reached a leaf node, the binary number stored in current is complete. We add it to the final answer. So we do self.result plus equal to current. And then finally we return. Once we process a leaf, we stop further recursion from that node, and then we go back up and try another path. We move the right child and continue building the number. We use the recursive DFS function. We define it like DFS of node dot right comma current. Here node dot right and current are the parameters, and then again we start DFS from the root. So we do DFS of root comma 0. Initial number is 0 because we haven't chosen any bits yet. Finally we return self.result. So after DFS finishes exploring all paths, we return the total sum. So now if we take a look at the code, it looks something like this. DFS walks every root to leaf path. Current variable builds binary numbers step by step, and at leaf we add to answer, and we finally return the final sum. So now let's try running the code. As you can see, the code runs with the optimal time complexity. So that's all for today. Hope you guys enjoyed today's video. See you in the next one. Bye bye.